All right, you guys, we've reached the end with our fifth learning target for IB AI SL2, which is a calculus application target. So this is an interesting one because it could have derivative applications or integral applications rolled up into it. First, I'll talk about derivative applications. The basic flow of all those problems is that you come up with some sort of, like maybe it's given to you, but usually there's some sort of model equation. This could be modeling a bunch of different things like surface area or, money and stuff like that. But there's some sort of equation, and then you use the derivative of that equation to find stationary points. To find stationary points, you have to set the derivative equal to 0. Then, depending on what type of problem it is, you can either solve it with algebra or you can solve it with a calculator. My recommendation is if the algebra is doable to do it with algebra, because sometimes the calculator steps can be, it can be an awkward viewing window sometimes, so you might have to do a little bit of guess and check with your window work to get a nice view to find the zeros, but yeah, so sometimes algebra is better. Sometimes you're forced to go calculator. Sometimes it's like a cubic, and you're like, oh, I can't solve that. Once you find those stationary points, the zeros from the derivative, you should be able to classify them. You usually do this with a little zone test. But you could also look at the graph of the derivative and see where they change from positive to negative or negative to positive. Remember, if it changes positive to negative, so we'll go plus to minus, that's a maximum. When it changes negative to positive, that's a minimum. And then if it goes like negative to negative or positive to positive, that is a neither situation. Integral applications. This one was mainly just finding the area underneath a curve. So you usually, they give you some sort of model, and then there's like you have to find a shaded area. We mainly did that with the calculator. There's two ways to do that. You can use fnint, which is in that math menu, or you could graph the model and then use in the calculate menu this integral where it shades underneath the curve. Those are basically the concepts. From there on out, it's really just making sure you know all the different types of problems that can come at you. So make sure you've tried all the problems I've thrown at you. Some ones that come to mind is like classic calculus application problems are the square corners cut out of the corners of a rectangle, and then you fold it up into a box. A lot of box with open lid problems where you have to find surface area or volume or something like that. Same thing, but with cylinders. There's a lot of surface area and volume with cylinders with these problems. Sometimes it's a money equation, where it's like a profit equation and you have to find a maximum, or it's like a cost equation and you have to find a minimum. Super classic problem is the three-sided pen on a farm to house animals. And then so these were mostly derivatives. Like this is mostly derivative stuff. The integration ones are a little more interesting because those are usually like, here's a graph, find the area underneath it. They're not anchored in real life too many times. The few times I've seen them model a real world situation is sometimes there's like a speed equation and given like a model, and then you have to integrate the area underneath it, which gives you the total distance that someone's traveled. That's the only one that really came to mind. I think if there's integration application problems on the test, they're mainly going to be like to find the area underneath a curve, or maybe, subtract two areas to find like a little missing part or something like that. Okay, you guys, good luck. Happy studying.